This set of notes is going to talk about the order of operations, and I just hope you guys don't think of the worst word that ever came into existence while you do this. I won't even say the word. It's a horrible word. So, order of operations. If we have an expression and we want to evaluate means to find a solution to solve. We're going to do it in a certain order to ensure that our math is correct. So the first thing we're going to do is we're going to evaluate all operations inside grouping symbols. Now, for some reason, people think parentheses are the only grouping symbols, but we have a lot more than that. So we do have the parentheses, but we also have what's called brackets, or these guys, the braces, which act as parentheses often. So if we see those in an expression, just treat them like parentheses. But also a square root groups some numbers together. I can put numbers in that. I can group numbers in a cube root. Why did I make that square root so big? Good Lord. I can group numbers in an absolute value sign. I also can group numbers using a division sign. I have numbers on the top. We call those our numerator. And on the bottom, our denominator. And again, I would evaluate the top, I would evaluate the bottom, and then divide. Step 2, evaluate all exponents and roots. So square roots, cube roots, because a square root and a cube root are actually a type of exponent. One thing you'll learn is that a square root, if I say x is the same as saying x to the 1/2, those two statements are the same thing. So we evaluate all exponents and roots. So if we have numbers in a square root, we evaluate the numbers in the square root, and then we find the square root. Then we perform multiplication and division from left to right. So if I see division first, can I do it first? You betcha. Because again, division and multiplication are actually the same operation. Division is just multiplying fractions. So for instance, if I want to divide 4 by 2, I can do it that way, or I can do it that way. Those mean the same thing. And then I would perform addition and subtraction from left to right. Again, why can I do subtraction before addition, or should I? I should do subtraction before addition, because -4 plus 3 is the same as 3 minus 4. Okay. Addition and subtraction are actually the same operation. It's just subtraction is addition of negative numbers. Okay. So let's do some examples. Example 1. We have the absolute value of 2 minus 5 plus 3 to the 3rd power all over 5 to the 3rd minus 9 plus 8. So we're going to evaluate the numerator. So we're going to evaluate the top. We're going to evaluate the bottom. And then we're going to have our solution, or then we're going to divide and have our solution. So we're going to find the quotient when we do that. All right, so what I like to do is work the top, then work the bottom, and then we'll divide. So let's work the top. So on the top we have the absolute value of 2 minus 5. Well, that is a grouping symbol. So we're going to evaluate what's inside there. So the absolute value of 2 minus 5 is -3 plus 3 to the 3rd power. The absolute value of 3 is 3. And then we have 3 to the 3rd. Notice I'm working down instead of across, because in algebra we move down. We get on down with algebra, so we move down. 3 to the third is 27, and then 3 plus 27 is 30. Okay, so we have evaluated the top. We did the grouping symbol, we did the exponent, and then we found the sum of those two things together. All right, now let's evaluate the denominator. So let's see, we have an exponent there, so we're going to do that first. 5 minus 3. 5 to the third power is 125 minus 9 plus 8. All right, we see that there's some subtraction there. In addition, that's what's left on the bottom. We can and should do the subtraction before the addition, no matter what that icky word says. That word, that horrible word. All right, 125 minus 9. 125 minus 9 is 116 plus 8. Let's see, 116 plus 8 would be 124. So I have 30 over 124. That doesn't go evenly, so I'm going to reduce. Let's see, 30 is divisible by 2. And so is 124. So 30 divided by 2 is 15. 124 divided by 2. Did I say 30 divided by 4 is 15? 30 divided by 2 is 15. 124 divided by 2 is 62. Again, use a calculator, check your work as you go, make sure you're doing it correctly. All right, so again, the order that you do these is important, okay? I hate it when someone says, oh, well, the answer could be this or this. That's not how math works, okay? When we're done with this, we should all end up with the same solution to these problems, because there is one solution to these problems. So let's do our next example. So our next example, we're going to have a square root in it and a cube root in it. So let me make sure I write this neatly so you guys can see my handwriting. So example number 2, -2, the square root of -2 to the 6th, plus the cube root of 5 minus -2 plus 2 times 10. Okay, so we're going to do the square root and the cube root. We're going to evaluate what is inside of them first, because remember, you take care of grouping symbols first. So anything inside a grouping symbol we're going to take care of. So let's do the first one. So we're going to do -2 to the 6th first. -2 to the 6th is going to be a positive 64, and the square root of 64 is, oops, I don't need that square root symbol anymore, is 8, because I evaluated it. So the square root of 64 is 8. So now let's look inside this cube root. So I'm going to put my addition sign here. I have -5 minus the -2 plus 2 times 10. We're going to do the 2 times 10 first, because we're going to do multiplication first before we can do any of the addition or subtraction. 2 times 10 is 20. All right, I'm going to add. We're going to do 5 minus a -2. Okay, so again, addition and subtraction, left to right. If we see subtraction before addition, and those are only two things left, we're going to do that subtraction. 5 minus the -2 is the same as adding 2, because we're taking away a negative, so we're adding a positive. All right, 5 minus the -2 is going to be a positive 7. Again, can you type in the calculator? By all means, double check your work. Make sure you did that right. Use it as a tool to help. So 5 minus a -2, same as 5 plus 2, minus a negative, same as addition, and then plus 20. All right, let's bring this 8 down again. 7 plus 20 is what we have left, so that's 27. And now we can evaluate that cube, and the cube root of 27 is 3. 8 plus 3 is 11. Again, taking a step at a time, we can evaluate any algebraic expression. All right, and we're just going to do one more example. So this is going to be example 3. This one's going to look real ugly, but we can do it. Again, step at a time. Which reminds me of the New Kids on the Block song, Step by Step. Which I don't think any of you know. I don't even know if any of you know who New Kids on the Block are. Step by step, ooh baby. Okay. Alright. This one's a lot like example 1. We got some grouping symbols, we got some multiplying. So let's evaluate the numerator, then we're going to evaluate the denominator. So on the top we have a cube root, and inside of that we have some addition and multiplication. So we'll do that multiplication first. 2 times 60 is 120. Right? 5 plus 120 is 125. And then the cube root of 125 is going to be 5. 5 times 5 times 5 is 125. Again, use a calculator to find that root if you need. All right. So now we're going to evaluate the numerator. So negative 3 to the third, and then we have plus 2 times 26. Negative 3 to the third is negative 27. 2 times 26 is what we'll do next. You could probably have done that in the same step, but that's all right. We're going to go step by step. All right. Negative 27. 2 times 26 is 52. Negative 27 plus 52 is 25. How do I know that? I typed that in the calculator. I'm not even going to lie to you. I was like, okay, negative 27 plus 52, and I was trying everything. I was like, I can do that in my head. I could not do that in my head. Tried my best. 25. All right. 5 divided by 25. I can reduce that. That's a reducible fraction. 1 over 5.